This is the 7th lecture in the FOA series on fiber optics. Lecture 7 is on fiber optic connectors, what they are, how they work, and how to install them. Fiber optic connectors are used to join two fibers together, as in patch panels, or to connect fibers to transmitters or receivers in transmission equipment. Of course, connectors are designed to be demountable. While they share with splices the requirements for low loss, low reflectance, and repeatability, connectors have the additional requirements of durability under repeated mating. The most important specification for a connector is loss. The drawing here shows some of the causes of loss, but most are errors in aligning the fibers. We also want the connector to be repeatable in two ways. If we terminate a lot of connectors, we need to be assured that most will have approximately the same loss, so we can plan on that loss for calculating the loss budget for that link. We also want it to be repeatable if we disconnect it and reconnect it many times. Reflectance is very important for laser sources, as reflectance can cause problems with laser transmitters. Plus, reflected light can create optical background noise, which confuses receivers. Connectors must also be designed to meet their specs over the environmental changes that it will see in normal operation. And of course, ease of termination and cost need no explanation. Here are 4 generations of fiber optic connectors, showing how their size in particular has shrunk. The bottom is the Deutsch 1000 from around 1980, one of the first commercial connectors. Above it is a Biconic, AT&T's first commercial connector, and the first connector to work with single-mode fiber. The SC from NTT was the first connector to use ceramic ferrules and have very low loss, even with single-mode fiber. It's still widely used today. And the LC from around 2000 uses a very small ceramic ferrule to allow the connector to be so small, and it offers equal or better performance than the SC. Here's the most popular connectors we see today. The ST and SC have been around since the mid-80s and use the same 2.5 millimeter ferrule. The LC came along in 2000 and has become the favorite connector of very high speed, greater than gigabit systems, because it allows the manufacture of very small transmitters and receivers. The MTP connector has been around for a decade, but is the choice for use in prefabricated cable systems that can be directly installed without field termination. As a connector itself, the MTP is not easily field installed. Connectors work by simply aligning the two fiber ends as accurately as possible and securing them in a fashion that's least affected by environmental factors. The most common method is to have a cylindrical ferrule, usually made out of ceramic, with a fiber-sized hole in the center in which the fiber is secured with an adhesive. Note that fiber optic connectors are mainly male style with a protruding ferrule, since the end of the ferrule must be polished after the fiber is glued into it. They require mating adapters for connections. Fiber optic connectors can have several different ferrule shapes. Early connectors, which did not have keyed ferrules and could rotate in mating adapters, always had an air gap between the connectors to prevent damaging the ends of the fibers. The air gap between the fibers caused both a higher loss and reflectance. Beginning with the ST and FC, connectors were designed with keyed ferrules which could contact tightly, what we call physical contact connectors, PC connectors, which had better performance. Making the connector with convex ferrules produced an even better connection. But the final solution for single-mode systems, extremely sensitive to reflections, is to make the end of the ferrule at an angle, about 8 degrees, creating what we call an APC or angle physical contact connector. Then any reflected light is at an angle that is absorbed in the cladding of the fiber. Most connectors are the simple adhesive polish type, where the fiber is glued into the connector ferrule and polished with a special polishing film. These provide the most reliable connection, lowest losses, and lowest costs. The adhesive may be epoxy, anaerobic, or hot melt, a 3M trademark. Crimp polish and crimp cleave connectors use a crimp to hold the fiber and in some cases avoid polishing at all. Poor performance of these connectors have hampered their acceptance. Pre-polished splice connectors have a short stub fiber already epoxied into the ferrule and polished perfectly, so you just cleave a fiber and insert it like a splice. These connectors are more expensive and have higher losses typically, but are quick to install. Let's examine the process of terminating fiber with a typical epoxy polish connector. Let's start by looking at the parts of the connector. These connectors have a body with a ceramic ferrule, a crimp sleeve used with jacketed fiber, and a strain relief boot to protect the fiber from being broken behind the connector. All connectors come with a protective cap called a dust cap, which should always be on the connector except when it's connected. After you remove the dust cap, the connector should be cleaned before connecting it, as dust caps usually contain dust. You will need to prepare the cable and fiber for termination. For jacketed cable, the jacket strip tool will expose the buffered fiber and strength members. Next, you cut the strength members to the proper length for crimping to the connector. Then you must carefully remove the buffer from the fiber with a fiber buffer stripper and clean the fiber carefully. The instructions for the connector you're using should include a drawing of the required dimensions of the prepared end of the cable ready for termination. If your directions only give dimensions, making an exact size drawing will be very helpful. For connectors using an epoxy adhesive, we have to mix the epoxy per the directions and fill a syringe to inject adhesive into the connector. You insert the needle into the connector body as far as it will go, lightly squeeze on the plunger until a bead of epoxy appears on the tip of the ferrule. Having the right bead of epoxy on the end of the connector ferrule is the most important issue for getting a good finish on the end of the fiber. The bead of epoxy supports the fiber during the polishing process and makes it just about impossible to make a bad connector. The proper bead will be 1/3 to 1/2 the diameter of the ferrule on the connector. Next, we insert the fiber into the connector. The way to do it properly is to slowly find the hole in the ferrule, insert the fiber very slowly, and rotate the connector to spread the adhesive carefully. Just be careful not to break the fiber. When terminating single fiber cable or zip cord, you must crimp the connector to mechanically attach it to the strength members of the cable. This is unnecessary if you're terminating a single tight buffered fiber from a distribution cable that has no individual jacket or strength members. Ensure the crimp die is the proper size and the aramid fiber strength members are captured under the crimp sleeve. The adhesive must cure before it can be polished. Most epoxies require an overnight cure, but most can be also cured very rapidly in a few minutes with a proper curing oven that is set at the right temperature. Once the epoxy is cured, the next step is to cleave the stub of glass fiber protruding from the ferrule using a diamond or carbide scribe. Discard the glass fiber fragment in a safe fiber disposal bin. Fiber shards are dangerous. They can stick in your fingers or get in your eyes and cause serious injury. There are several stages in the polishing process. First, we air polish the fiber stub with 12-micron film, holding it as shown, for only 10 or 20 seconds. Final polishing is done in 1 or 2 steps on finer grades of polishing film. It can be done by hand, or in the factory it's done by machines. Typically you polish in a figure-8 pattern. One thing to remember is don't over-polish. Over-polishing a connector will cause higher loss and higher reflectance. Inspect the polish end of the ferrule with a microscope to see that the epoxy is completely removed and the tip is smooth and free of scratches. There are many inspection microscopes available with magnifications ranging from 100 to 400x. Higher magnification may not necessarily be better, as it tends to make you more critical of scratches and imperfections. Anaerobic adhesives can be used instead of epoxy for a quick termination, taking only 30 seconds to a few minutes. The adhesive can be wiped on the fiber or injected into the connector with a syringe. A liquid accelerator can be used to make the adhesive set immediately, or it can be left to set in a few minutes. 3M hot melt connectors use an adhesive preloaded into the connector. The termination process involves heating up the connector until the adhesive becomes hot and a liquid, then inserting the stripped and cleaned fiber into the connector. It is then set aside to allow the adhesive to cool and set before cleaving and polishing. Some manufacturers now offer connectors that have a short stub fiber already epoxied into the ferrule and perfectly polished, so you just cleave a fiber and insert it like a splice. Most use mechanical splices, but some are now using fusion splicing techniques. It's important to follow the manufacturer's process exactly when terminating pre-polished splice connectors. The usual process is to insert the connector in the fixture, strip, clean, and cleave the fiber, insert the fiber in the connector, and crimp it. You can often verify the splice with a visual fault locator. The FOA has a YouTube video showing how these connectors are done in more detail. You may not need to do field termination at all. You can design a prefabricated cabling system using a computer-aided design system that you just install and test. Systems now work for both premises and outside plant installations, and they can be very cost-effective in new construction. Talk with the fiber and cable manufacturers about your options. The FOA has many YouTube videos on splicing and termination. Check the FOA channel, the FOA Inc., for currently available videos. We're the Fiber Optic Association, the worldwide professional society of fiber optics. For more information on fiber, especially detailed technical information, refer to the online reference guide on the FOA website.